geometry, we are kicking off Unit 7, talking about the interior and exterior angles of polygons. And this is going to kind of launch us into Unit 7, which is all about quadrilaterals. And one of the terms that we're going to talk about with quadrilaterals are diagonals. We talked about this way back when, probably one of the first objectives of the year. But what is a diagonal of a polygon? We know what the direction diagonal means, right? You've got a vertical line, a horizontal line, or a diagonal line. This is a little bit different. A diagonal of a polygon. Anyone know? We're going to learn something new today. That's fantastic. Did you guess?
Is it when the segment is extended?
Nope. Not a bad guess, though. Kylie?
Is it like a line from one angle to another?
Ah, yeah, very close. A diagonal is a segment that connects two non-adjacent.
Why did you say adjacent?
Because that's the word.
Yeah, but I don't know what that means.
Oh, boy. Two non-adjacent points. A segment that connects to non-adjacent points. Now, we first talked about the word adjacent last unit. What does the word adjacent mean? Next to. So non-adjacent would be not next to, right? So, for example, in this first one here, drawing the diagonals, if we start at this vertex here, okay, or this point, we can't draw a diagonal to the point immediately to the right of it, because that's the side of the polygon, okay? But we can draw a diagonal down here and a diagonal over there, okay? We've connected those two non-adjacent points to our starting point. Now, if we go over to this one here, we can draw a diagonal down here, a diagonal over here. We just kind of move around the figure now, this point in the bottom right corner. We've already drawn the diagonal up to the top, so we're not going to redraw it. But we can go up here. And then the final 2 points, they've already got the diagonals drawn in there. So basically, there are 1, 2, 3, 4, 5 diagonals that can be drawn inside this shape. What's that? I did.
Good
math.
shape, Joey.
Math. Claire.
Is the number of lines just how many vertexes they have?
Yes and no. Okay, so Claire's making the connection here that in this pentagon, 5-sided shape, there are 5 diagonals that we can draw. Okay.
I'll do the next one.
The next one has what? Octagon, 8 sides.
Let's do it.
So let's start. Let's start in the upper left point here and draw your diagonals in. We've got 1, 2, 3, 4, 5 from that one alone. I'm going to switch up colors here just because it's hard for me to keep track of all these lines going everywhere. I'm not bright enough. But going over to the upper right here, we'll do it in blue. We can draw another one down here and there, all the way across. I think we've reached our 8. That looks kind of cool. It's like 2 spotlights shining down on a stage or a spider web or something, doesn't it? Neato. And then go over to the next one. Do this in red here. And we go down and there and there and there.
What the heck?
Yeah. Woo! That's not what? No, it's not. It gets kind of jumbled in a hurry here. And then just go around again, do this one in black. We've already drawn one diagonal going up in blue there from the previous point. So we're going to skip that one, but we're going over here, straight across, and up there. Basically, the point is here, okay, that the more your sides increase, the more diagonals can fit within the figure. It increases exponentially, increases very, very quickly. Okay, so we're not going to draw the rest in here. You can see kind of the design that's starting to be formed. Okay, and there is a lot of art out there, especially in graphic design, that involves connecting the diagonals of figures. So if you take a graphic design course in high school, you'll come back to this, but this is not an art class, so we're going to stop here. Okay, but there you go. So diagonal. The important thing to know what it does is it connects two non-adjacent points within a polygon. The polygon interior angles theorem. This is to determine. I should say calculates, not determines. It calculates, because this is what the interior angles theorem does, and I'll tell you what it is. But it calculates the interior angle measures of a polygon. So, I'll sure cut that down. Calculates the interior angle measures of a polygon. How many degrees does a triangle have?
180.
180. How many degrees does a quadrilateral have?
360.
360. And we preface this by talking about all those different ones: parallelograms, rhombi, rectangles, heights. It doesn't matter. Any four-sided shape will have exactly 360 degrees in it. Okay. Anyone know for a pentagon?
Yeah, 590.
Not 590.
580.
540.
540. How about a hexagon?
720.
720. So when you watch like
Probably 120.
snowboarding, skiing stuff, and some says, "Whoa, they pulled off a half pipe 540 flippity doodah." They're talking about that 540 is the rotation, okay, that they went there. And so how you calculate that? The formula for a polygon with n sides, okay, this is the theorem here now, for a polygon with n sides, n being 3, 4, 5, 6, whatever, your formula is 180 times n minus 2. Okay, 180 times n minus 2. So if you think about a triangle has 3 sides. 3 minus 2 is 1 times 180, 180 degrees. Okay, a quadrilateral has 4 sides. 4 minus 2 is 2. 2 times 180, 360 degrees. Okay, so this formula states that for every side you gain in a polygon, you're gaining 180 degrees for the internal sum. So if you, it's kind of cut off down here at the bottom, but the first homework question there says, what is the sum of the interior
Angles of
an octagon? Okay, how many sides does an octagon have? 8. So this little formula, 180 times 8 minus 2, or 180 times 6, that's going to give you the answer. Okay, 1,080 for those stats.
How do you design your head?
I've done this once or twice before.
That's wrong.
Is it?
It's 1,080.
That's what I said.
You said 8.
You said 6.
I said 1,008?
I
Well, that would make any sense. There's no way it would not end in something other than a 0 if we're adding.
heard 1,006.
That's what you heard?
Yeah,
I
I'm
see.
not
Okay.
kidding.
The polygon for an exterior angles theorem is much more straightforward. This states that the exterior angles, I don't know why my board's glitching here, but the exterior angles of a polygon will always sum to be 360 degrees. The exterior angles of a polygon will always sum to be 360 degrees.
You said will someday. You said say always.
Not bad.
I'm ready.
That's fine. let's look at some examples here.
What happened to the buttons?
Oh, I forgot to put them up there. It's been a while. What is the sum of the interior angles of an octagon? We already said that's 8-sided shape. So 180 times 8 minus 2, or 180 times 6 is 1,080 degrees. Sure, enunciate there. What is the sum of the interior angles of a 13-gon? Noah?
1,980 degrees.
So we're going to take 180 times 13 minus 2, or 180 times 11, and we got what?
1,980 degrees.
Right?
Can we second that?
Do we have a second on that?
Yes.
Okay. And then the sum of the interior angles of a polygon is 900 degrees, classified by its number of sides. In this case, we're kind of going the other way, right? We know that this formula will tell us the number of degrees inside of a polygon if we know the number of sides. Well, if we know the sum of the interior angles,
Seven.
we can then solve for n. Okay? How? How would we go about solving this? You could distribute the 180. What else could you do?
Divide 900 by 180.
You could start by dividing 900 by 180,
And then you're done.
because that's going to leave us with n minus 2 equals 5.
So that equals 7.
Add 2.
And then add 2 to both sides to get n by itself, and n will equal 7. What kind of shape has 7 sides? Septagon, heptagon, either way. Okay. Ellen said you could distribute that 180 into the parentheses first, and that would give you the expression 180n minus 360 equals 900. Add 360 to both sides, divide by 180, that would give you 7 as well. So it doesn't matter which way you go at it, you're going to get the same answer anyway. And then finally, what is the value of x? This is an example of exterior angles. Remember, we talked about exterior angles back in PO17. They're the angles that are formed when a side is extended, right? So 89 degrees there, 67 here, x and 2x here. How do we go about solving for x here? What do we know about the exterior angle of a polygon? Yeah.
The exterior angles will always sum to be 360, so you could do 360 equals the numbers there.
Yeah. So we know that 89 plus 67 plus x plus 2x have to sum to be 360.
How do we know it's 360?
We know it's 360 because that's what the exterior angles of a polygon tells us. Okay. Luckily, there have been people that have come before you that have made these theorems, discovered these theorems, written these theorems, so that you don't have to figure it out. Okay. It is understood. It's a mathematical law. So, simplifying, you are very lucky. What a time to be alive. 360, 89 and 67 is what, 156? And we have a total of 3 x's there. X plus 2x is 3x. So, subtract 156 from 360. That gives us 204.
204 equals 3x. X equals.
And divide both sides by 3. I got 68.
Second that?
68 is your value for.
I second that.
Okay. So, just a couple theorems to better your Tuesday for telling how many degrees the interior angles of a polygon, what they sum to be, as well as what we already know about the exterior angles of any polygon, no matter how many sides. Yes.
Which one does Vince sit there? Yeah, blue.
Better than being moved out in the hallway, though. So there's that. Ellen.
So there's like
Nice to get that.
interior angles that you can use for a triangle, but could you also use this for a triangle? Exterior?
Yeah. So Ellen's asking, how does the exterior angles theorem that we have for a triangle combined with the exterior angles of a polygon theorem? So if you remember, and I think that's what you're asking, right? Or no? What? Answer your question again.
Well, there's that pair where you can
Shh.
find, you
Go
can
on, go
find an exterior angle with the interior angle.
Yes.
But could you also find an exterior angle with other exterior angles? in
Yes.
that angle?
Yes. So if you remember way back in PO17, when you have the exterior angle of a triangle, call this angle 1 and angle 2 and angle 3 here, we know that the measure of angle 1 is equal to the sum of the measure of angle 2 plus the measure of angle 3. Okay? That's what the exterior angle of a triangle tells us. The exterior angle of a polygon tells us that the sum of all those exterior angles will sum to be 360. So in this case, if we extended these sides, okay, and so we had angles 4 and angle 5 here, we know that 1 plus 4 plus 5 have to equal 360. And we know that angle 1 is equal to 2 and 3. So we can't really combine the two without more information. But the exterior angles of the triangles, they are kind of extra special in that they give us two theorems that we can use in different situations. Okay. Yeah.
I have two questions.
Yep.
So one, can I move next?
Nope. Second
Okay.
one.
You're telling me you moved Vince next to his best friend?
What? No, I'm his
Jack
best friend.
sits there.
It's his
He
imaginary friend.
moved him away from me. Like, obviously he.
Away from
See,
Joey to
the
right
problem with
next to
having so
Jack.
many friends is that it can be difficult to
No,
move away from.
No, I'm his best
I
friend.
mean, there's always right behind
No,
him.
I'm his best
I
friend.
mean, I don't have very many friends, but I mean,
You will.
Wow.
Just kidding, good too.
To hear that
Wow.
shade,
This
is
wow.
oh boy,
There's a lot of
I don't know.
that might
Not
say,
very
yeah,
many,
I think
but-
Ellen hit the nail on the head there. Okay, your assignment due tomorrow.
it was. It was literally quiet. I guarantee it was.
On page.
See, this is not willing to admit. It wasn't easy. I was watching TikTok.
On page 510.
But it actually could have been one.
What's it all dead?
Oh my God.
Folks, 510. I'd like you to do 3 through. No.
No, guys, let's be serious about one.
Let's be.
3 through 7. 3 through all. Matt.
Three through 16.
16?
Make sure you show your work.
No.
If you borrow a book from the back, make sure it gets returned. This is due tomorrow. That's how you math. Like it.